Greetings! Now we're going to do 4 examples of logarithmic differentiation. Alright, so we want to take the derivative of 5 to the x. And to do this, we're going to use logarithmic differentiation. And so the first step will be, I'll set f of x equal to 5 to the x. Now, I'm going to take the natural log of both sides. So I'm going to write natural log of f of x is equal to natural log of 5 to the x. Alright, and if you remember your log rules, you'll see that natural log of f of x is equal to x times natural log of 5. So now what we're going to do is we're going to take the derivative of both sides. Using the chain rule and what we know about log, the derivative with respect to x of the left-hand side is going to be f prime of x all over f of x. Now this is equal to the right-hand side, but the right-hand side is considerably easier. What we have here is x times a constant, and we know that the derivative of x times a constant is just that constant, natural log of 5. And so this tells us that f prime of x is equal to natural log of 5 times f of x, and f of x is 5 to the x. So this is equal to natural log of 5 times 5 to the x. First example, done. Next example. So now I want to take the derivative with respect to x of the square root of x to the x power. The first thing I'm going to do is I'm going to rewrite this a little bit to be the derivative with respect to x of x to the 1/2 all to the x power. And I can rewrite this again as the derivative with respect to x of x to the x over 2. Okay, now I'm going to try to use logarithmic differentiation. And the first step will be I'll set f of x equal to x to the x over 2 power. Now I'm going to take the log of both sides. The natural log of f of x is equal to the natural log of x to the x over 2. And now I can use log rules to bring down the exponent. So I have natural log of f of x is equal to x over 2 natural log of x. And so now I'll differentiate both sides. And the left-hand side I'll differentiate using the chain rule, and I get f prime of x over f of x. On the other hand, the right-hand side, what happens is I have to use the product rule. And so the derivative of x over 2 is 1/2 times natural log of x. Now I add this to x over 2 times the derivative of natural log of x, which is 1 over x. Now these x's cancel, and I'm going to obtain f prime of x over f of x is equal to 1/2 natural log of x plus 1/2. And now I can multiply both sides by f of x, and f of x is equal to x to the x over 2 power. So f prime of x is equal to x to the x over 2 power times 1/2 natural log of x plus 1/2. Second example, done. Third example. So now I want to take the derivative with respect to x of x to the natural log of x. Again, I'm going to use logarithmic differentiation. So I'm going to write f of x is equal to x to the natural log of x. Okay, and now I'll take the natural log of both sides. So I write natural log of f of x is equal to natural log of x to the natural log of x. Wow. And now, using log rules, I know that natural log of f of x is equal to, well, I can pull the exponent out front. So that's going to be natural log of x times, oh, this is interesting, natural log of x. Okay, well actually, I can simplify this quite a bit. I can say this is natural log of x squared there. Okay, well that's interesting. Natural log of f of x is equal to this. Okay, cool. Now I'm going to take the derivative of both sides. And if you recall the chain rule and facts about log, when you take the derivative of natural log of f of x, you're going to have f prime of x all over f of x. And if I take the derivative of the right-hand side, it's going to be 2 times natural log of x times, well, what's the derivative of natural log of x? It's 1 over x. That's using the chain rule. Aha! So this tells me that f prime of x is equal to x to the natural log of x all times 2 natural log of x all over x. Third example, done. Final example. So now I want to take the derivative with respect to x of natural log of x all raised to the power x. Again, I'm going to use logarithmic differentiation. So I'm going to say f of x is equal to natural log of x all raised to the x power. And so now I'm going to take the natural log of both sides. So let's write natural log of f of x is equal to natural log of x to the x. But now I can use log rules and take this exponent out front. And so I'll write natural log of f of x is equal to x times natural log of x. And you may be thinking, when would we ever see natural log of x? Well, it comes up in number theory. That's pretty interesting, I think. Anyhow, let's take the derivative of both sides. Now, using facts we know about a natural log and the chain rule, we see that the left-hand side is equal to f prime of x all over f of x. And the right-hand side, well, for the right-hand side we have to use the product rule. And so let's take the derivative of x first. So it's going to be 1, and then take 1 times natural log of x plus x times, and now what we're going to do is when you have the natural log of a function, it's going to be 1 over x times natural log of x. And so this is equal to, I'm going to simplify just a little bit, natural log of x plus, these will cancel, 1 over natural log of x. And so now if I multiply, this is f prime of x all over f of x. If I multiply both sides by f of x, we get that f prime of x is equal to natural log of x all raised to the x times natural log of x, make sure I have my parentheses all right, plus 1 over natural log of x. There we go. Final example done. We've done 4 examples of logarithmic differentiation. I gotta tell you, I think logarithmic differentiation is kind of fun. You know, you're going around, you have your f, and you take the derivative, well, whatever. Anyways, let's go do some more math.